This is the modules that we developed, the individual modules for the sensor network that we developed. So it has an image sensor attached to it, and then we're using a Raspberry Pi as our embedded computational module. So the Raspberry Pi is actually triggered to capture on an interrupt, and so we'll be using an IR filter or an IR motion detector, and we have it set up here just for demo purposes right now. And so it triggers the LED here as it receives motion.
There we go.
And so that would trigger an interrupt, which would cause the Raspberry Pi to capture an image from the camera here, at which point the picture parsing software goes into effect and breaks that up and sends it over the network, which Seth's going to describe.
Sure. So the network is powered by a bunch of XP radio modules. They work in a mesh network. So we're sending data over the network via wireless communication. So what we have to do is from the Pi we have to send the picture over in bits to the gateway node right here. The gateway node collects all the images or the image parts, and once it has all the parts, it will send that image to our big computer right here, which will run the computer vision algorithms. And once it has a result, it'll tell the gateway node, hey, here's what we got from the trail, and then the gateway node will update the database, which will update the website and everything else.
Each of our systems are very decoupled from one another, and so what's interesting is the call from the gateway node to the CP computer is done via a REST API, and it's just an HTTP post and get call, which right now we happen to be using ICF as our pedestrian detector, but we can potentially swap that out for any number of algorithms in the API depending on what the individual application of the network might be. So while we're using it right now for pedestrian detection, we could easily adapt the wireless network for other use cases.